Hello, my name is Tyler Basundiel from Baltimore, New York. The focus of my research project is to develop strains of radishes that can tolerate high salt stress. Soil salinization is an emerging problem that faces crop production. It is estimated that over 50% of arable land will be salinized by the year 2050. Soil salinization is caused by poor irrigation practices, flooding, and the rising water table. There are many ways that soil salinization can affect crop production. Salt can restrict germination and growth, as well as lowering biomass. It is important to develop plants that are able to survive in high salt conditions to help remediate this global threat. These images show how plants can be greatly affected by salt stress. The image on the left shows how salt can kill plants after salt treatment, causing them to wilt and die. The image on the right shows necrosis, which is one of the effects of salt stress. Salt can lead to a breakdown of the chlorophyll in the plants, which will decrease the level of photosynthesis. Eventually, the plant will not be able to make food and will die. For my project, I chose to use the radish plant. The radish plant is salt sensitive and it has a great economic importance in many parts of the world. The objective of my research is to develop a salt-tolerant variant. To do this, I needed to identify the concentration of salt stress that would restrict plant growth. I treated plants with 75, 50, 200, and 300 millimolars of salt. As you can see from this picture, a high salt concentration was able to reduce the growth of the radicle, hypocotyl, cotyledon, and chlorophyll production. 150 millimolars had a complete inhibition of growth. Using 150 millimolars as the baseline concentration, I treated thousands of cobalt-60 irradiated seeds in high salt conditions. I selected seeds that germinated with an elongated hypocotyl radicle and expanded cotyledon. Of the thousands of seeds, only 3 developed. I planted them in soil and allowed them to grow and produce seed pods. I harvested the seeds from these pods and retested the F1 seeds to see if they're salt tolerant. When I screened the F1 seeds, 17% of the F1 germination produced seedlings with expanded cotyledon and elongated hypocotyl. This shows the trait for salt tolerance was passed down from the parent to the F1. Recently, I screened the F2 generation after harvesting from the F1, and I found that many of the F2 seeds are able to grow in 200 millimolars of salt. In conclusion, I identified putative salt-tolerant mutants that can grow in high salt conditions and reproduce down to the F2 generation. In the future, I'd like to grow the F2 generation to maturity and see if they can survive gradual levels of salt.